Okay, so to get a continuous function with this expression, we need to take into account that when we factor the top, it's actually a difference of squares. Even though neither term is inherently squared, x is the square root of x squared, right? And so the factoring that we can use for substitution is this here, right? That x minus 4 can actually be written as the product of root x plus 2 and the root x minus 2. And when we have that, we get x minus 4 on top over root x minus 2 on the bottom. But then the factored form, we end up with root x plus 2 and root x minus 2. And when we divide by root x minus 2 and cancel these factors, right, this causes a hole at the point where x is equal to square root of 2. And generally this, if for a continuity problem when you're talking about limits, right, you can say, well, the limit as x approaches root 2 still exists even though the function doesn't exist. But certainly f of root 2 is undefined because you have 0 over 0. In order to make this a continuous function, sorry. This hole is actually at root 4, is actually at 4 because the square root of, anyways. Let's pick up from there. So the hole is at x equals 4. And so if you take this function, f of 4, this is undefined. And in order to fix that, we have to figure out what the value of the simplified form, which is root x plus 2, this is what the rest of the function would look like. And so if we plug in root 4 plus 2, right, the hole occurs at the point 4 comma 6, right, is the location of the hole. And so in order to write a function that is continuous, we would write it as a piecewise function, right? We would write f of x should then be the original function x minus 4 over root x minus 2, right, for places where x is not equal to 4, right? And then we could just give it the proper value 6 because this would fill in the value of the hole, right, when x is equal to 4.